start the hangout pretty quick here. Let me see if I can turn this down. Test, test. All right. Okay, so yeah, get I guess first announcement. So if you haven't been here, washrooms are down the hall and then down the stairs, and we'll get started in just a couple minutes here. So when Terry gets back, you can get your last beer order in. All right, so I'm going to share with you, and you're on screen. Oh yeah, please. Thank you. Forgot. Did I kill your?
I think you ordered a beer for me. Maybe?
No, I took that.
Did you order a beer for me?
No, sorry, man. You were talking about wine, and then I was like, well.
Do you want to do red or white?
Red.
Okay, so I have a cat on
Okay, okay. We'll see if Mike's laptop will keep up. So, all right, so thanks for coming, everybody. I know it's nice out, so we'll try and keep this temperate, and then we can just roam. All right, so Mike's going to be presenting today. I'm bailing. I'm actually slammed with work, so I'm actually going to be presenting probably both stuff next month. So we're going to be talking next month. We'll be talking about Docker and then microservice stuff with the framework that Dave and I wrote, and now have a bunch of contributors on. So some of the people in the crew here, we've got Cleo, so Tice is from Cleo, and you guys are still hiring, I think, always. They're always hiring, they do remote work. What positions are you guys hiring for right now?
Yeah, so we got our highest priority hires are JavaScript developers and Android developers. We also have open Rails developer position, but that's out of Burnaby. The other two would be remote though.
All right, and I've heard from people that work there too. Really sweet culture. So Tice has been there for a long time. He's one of the original crew. So 7 years, yeah. Good for you, man. Good for you. So we got Pixis Innovation. They're one of the sponsors. They do a bunch of GIS stuff. I think they are actually looking for some GIS people. If that's your thing. You're here down at Last Best, and then there's 3SI. They've now bought, or they got bought or partnered up with Enerflux, and then App Carousel. App Carousel is looking for people too. I think Android devs as well, and iOS devs, and maybe JS too. Anyway, if you're looking for work, there's a bunch. Good Bits and Lighthouse Labs and Assembly, they're all good stuff. So we got some of our community pals. So this session, so like last session, we did partnership with the functional programming group, and this session is a collaboration with PyYYC. So they've got when's your guys' meetup? Your next one? Next Tuesday, and that one's down at Assembly, right? So you guys, it's Assembly on 14th Street. So Mike's going to be talking about kind of the JS side of microservice stuff, and then over next week he's going to be talking about some of the Python side. So you get to see kind of both sides of how this works. And then that's not what's coming next month. Oops, I forgot to edit that. So next month I'll be talking about Node.js. Well, basically, like I said, Docker stuff with feathers. Yeah, I know. It's because we're going through the internet all the way down to California probably, and then back up. Okay. So I'm going to stop presenting, and we're going to switch to Mike. And Mike's gonna, you got to share your screen on Hangouts if you can with me. And then I will give you the mic and you can do your thing. All right. Great success. Oh, disappeared. Just bear with us. It's always a little tricky getting the Hangouts to play nicely. Perfect. I can close this, and I can open this. Well, you're good to go. There you go, dude. It is still sharing.
Okay. Okay. Yeah, if anyone. Do you want to?
Sure. Sorry, I was going to do my part. We'll clap for Mike again. So I guess what I'm going to do is kind of intro microservices and why they are good and why they're not so good. And then you get to be the judge, and Mike's going to kind of show you one of the pretty sweet open source tool that comes out of Germany, I believe, right? That you're paid to work on. And that is one of the microservice frameworks out there. So who's heard of the buzzwordy term microservice? Do you guys? All right. So most people. Okay, sweet. All right. Who has set up a microservice architecture? Ah, a couple. Nice. Okay. Sweet. So then some of this stuff might not be that new, but basically, so the concept of service-oriented architecture is to basically take your monolithic application that has your models and your controllers and your views and stuff, if you're following an MVC pattern, and split it up into logical services so that they, I guess, like, without getting too academic about it, so that they have one individual focus. Right? So a good example is like an authentication service or a payment service or something like that, right? And the reason you do that is there's two reasons. So one of them is an organizational slash, I guess, sort of company culture or like scale issue. I mean, they basically revolve around issues of scale. So the first one is you have too many people in your company working on the same code base, right? So it doesn't matter if you're using any version control, like with Git, SVN, whatever, even if you're following good branching structure, if you have a shit ton of people working on the same code base, you're going to end up with a bunch of merge conflicts and a bunch of code changes that are going to be a super big pain in the ass to resolve. So that's the first one. The other one is around companies, like basically traction or scale for your application. So if you're getting a bunch of traffic towards your application, it might not make sense, or it might be too hard to actually service all of the connections that you need within one single application. And you can scale, horizontally by running a bunch of servers and load balancing, but sometimes that still just isn't quite good enough, or it could be easier or better if you're running smaller services that, especially when you've got smaller services that take more of the traffic than others, right? So those are kind of the two main reasons. And so that's a service-oriented architecture, and microservices are basically just a really stripped down or slimmed down version of a service-oriented architecture, or SOA. So the idea is that basically you try and even AWS Lambda, who's heard of that? Cool. Has anybody tried it? Yeah, all right, sweet. So even AWS Lambda takes it, so that basically they take it a step further, and instead of having really small applications or really small services that do one thing and do one thing well, they actually use it at the function level. And you can kind of slam stuff into Lambda so that you're actually running a whole service inside of Lambda, and like you can kind of bastardize it. But the whole point was basically to run only have your functions that get run more frequently. They're all segmented, and the beauty of that for Lambda is that you actually only pay for when your functions run, as opposed to having to pay for a server that's running and it may not be utilized, right? So that's kind of the plus. And so I guess if we were to back up and go to microservice, so if we take the example of payment, so in a typical payment flow, you might have something like taking a credit card. So let's say we're using Stripe, right? So you take a credit card or you take the token that you get back from Stripe, and you need to create a customer because this customer's new, so you need to take their billing info, and you need to actually charge their credit card, which you offload to Stripe, and then you actually need to maybe generate a receipt and all that sort of stuff, unless you're doing it with Stripe. Basically, like, you need to do a whole bunch of steps, right? So if you're just following an SOA setup that is a microservice, you might have one payment service. If you're doing microservice stuff, you might actually break it down into like a card service, a customer service, a receipt service, things like that. So it's still kind of wishy-washy because it really depends on how you want to break up your application. And basically the big plus side is that in an ideal world, you're doing one thing really well. It's easier to catch bugs because your services are smaller. You can scale, because you can basically just spin up more services, and if they're load balanced, then you can handle a lot more traffic. If you're using stuff like Lambda, potentially, you can save a bunch of money. So that's kind of the pros. The cons are that you have a lot of moving parts. So you need some DevOps chops. There are tools that help you out, but you need to kind of be able to orchestrate all of these different services, right? And they all need to talk to each other. So that's just on kind of the production level. Managing them all is a lot more overhead, right? So there are trade-offs, and it's not for everybody. You shouldn't be going into a new project, especially saying like, hey, I'm going to do microservices. It's way overkill, really, for what you need. Most of the time, most people don't hit the level of traffic where you actually need it. And shameless plug, that's kind of what we've been trying to do with Feathers, is that you can start off with a monolithic app where everything's all in one app, but it's structured in a way that it's easy to decouple into services when you need to, because I've been through that pain with a few different companies, and that splitting out a monolithic Rails app is just, we're talking years of work, hundreds of thousands of dollars, or excuse me, or millions of dollars. So it's really expensive. So I guess the other kind of cons on an SOA in general, DHH actually has a pretty good Medium post about it called the Majestic Monolith. I don't agree with everything in it, but the biggest thing that I've run into is orchestrating your services on the production level is hard, but you have to think you also have network issues. You've got potentially network latency. You have to worry about securing all of these servers in terms of preventing DDoS attacks or security breaches. So there's a lot of DevOps work, but and then you're also going to have to replicate that probably for a staging or a test environment, which is where automation tools come into play. But also the biggest pain, actually, I think, is for local developers. When you have a bunch of services like that, it is so hard, can be so hard to get somebody up and running as a new employee and get somebody onboarded, because they have to now understand all of these services, how they all talk to each other. They have to have their machine configured, And there's some tooling that makes it better, but frankly, I think it's still not great. It's not as good as it should be. And I think that's the real big, like those are some of the drawbacks to microservice stuff. So that's kind of why I think you should not rush into it, but it's good to be aware of the why it's good and why it's not. And with that, I'll hand it off to Mike for real.
Okay. Yeah, I do have a little bit of a cheesy demo later on. So if you guys want to play along, you can go to this website here and download the code, play along with the slides if you want. In theory, it'll even work on your phones. So my name is Mike. Sorry, it's just yycjs.media.ca. All right, everyone good? So my name is Mike. I've been working as a contractor on crossbar.io for the last about year. It's an open source sort of ecosystem, if you will, I'm going to tell you about tonight. So there's a lot of parts. I'm going to gloss over some, but I hope to give you the sort of main flavor of what it is and what it does. Yeah, so it's called, I'm going to tell you about WAMP, which is a specification for a protocol, a web application messaging protocol. And the libraries that sort of go along with that, which are called Autobahn. And there's yeah, it's not to be confused with the other thing called WAMP. There's a router for this thing called crossbar, and there's even a demo, like I said. So web application messaging protocol, not whatever the other one stands for. I can't remember. Yes, sadness. So what WAMP is a protocol and a software that lets you do two sort of popular distributed computing patterns, remote procedure calls and publish and subscribe. So over the internet locally, this is a routed protocol. So that means that there's a central router that everything goes through, which has its own pros and cons. So it's sort of the opposite of peer-to-peer. I'm going to tell you about crossbar.io, which is one WAMP router. There's other ones, which I'll tell you a bit about. And I'm going to tell you about the Autobahn sort of client libraries. Tonight, I'll tell you about the JS one. Next week, I'll tell you about the Python one. And there's a bunch of other client libraries, both provided by Crossbar, crossbar.io ourselves, and a bunch of third-party ones. So why would you want to use WAMP? Eric gave you a little, pros and cons of why you might want to do sort of microservices. This talk is sort of assuming you want to do microservices or a service-oriented architecture. Why would you choose this particular one, right? So you get these two simple and pretty popular patterns for distributing your system, and they work across a bunch of different languages. Okay, so this isn't like just JavaScript or just anything else. So Autobahn provides libraries for JavaScript, Python, C++, and Java right now. There's a C library for embedded systems coming soon. And there's a bunch of third-party implementations in, there's two other JavaScript implementations. There's a a third-party Java implementation, and then there's C# and Erlang and all the popular languages. Just kidding. But yeah, there's quite a few, and WAMP is really flexible on how you can choose to integrate it into your system, and how you can deploy it. So you can you can have sort of crossbar do everything. It can be your web server. It can terminate your WebSocket connections, or you can run sort of Nginx or something in front of it, and this can just be a piece of your architecture. The actual protocol itself has a pretty good specification, and it's currently in the ITF process to become an RFC, so it's sort of getting better. There's a bunch of third-party implementations which helps flesh out problems with the spec. And there's also other routers, right? So if you don't like the way crossbar is, the way crossbar works, there's a couple other routers out there that you could choose to run. And so just to explain, so remote procedure calls, like they sound, they're a way to sort of make something that looks and seems like a function call over the network. Okay, so you can register and say, hey, this program over here is offering a function that you can call, and then some other component in the system, possibly in the same machine, but could be across the internet somewhere, can call that function. And then publish and subscribe is pretty similar in a lot of ways, but typically what you have is something somewhere publishes an event, and it goes to a bunch of other systems called the subscribers. And so usually PubSub has sort of one or two publishers and a lot of subscribers. And usually RPC or remote procedure calls have sort of one thing talking to one other thing. I mean, you can kind of do them with each other, but and WAMP in particular, like I said, is a routed protocol, or it has a router, an explicit router, which means all of these things, all of the registers, all the calls, all the publishes, all the subscribes, go through a central thing, the router. And so, if you're looking up sort of pattern stuff on this, that's the broker and the dealer. Now there's I'm just gonna gloss over that. So there's good things and bad things about that. With this centralized place where all these things go through, you can do, you don't have to worry about, we're supposed to have IPv6 by now, but I guess we don't. So you don't have, and so NATs are still a big problem on the internet. You can't, it's hard to set up actual peer-to-peer connections from like that phone to that phone because, or well, maybe if they're on the same Wi-Fi router, it's okay. But in general, it's hard to make peer-to-peer connections across the internet. And so with a router, as long as the router is visible on the internet, everything can connect to it. And then that sort of makes a lot of these NAT sort of problems go away. You can do some pretty fine-grained permissions stuff at the network level. So you can disallow certain pieces of your system from calling other pieces, right? You don't want your, the client on their phone who's trying to, read the chat room. They don't want to be able to do things to your admin interface and stuff. And it's a bit easier to guarantee those things when you have a central place where all the messaging is going through. You can also do some interesting sort of orchestration type things, like setting up, tearing down services, setting up services in sort of one location in response to stuff happening. And then there's obviously some bad things about that too. You've got a single thing, the router. If it's gone, that's your single point of failure, and nothing's going to work anymore. And of course, bandwidth can be a problem, right? If you've got 10 million clients and they're all going through the same the same router, you might have a lot of bandwidth coming through one sort of place on the network. So let me tell you about Autobahn, which are the libraries that speak this WAMP protocol. So starting with the transport layer, so how you get bytes sort of from one place to another on the internet or on any network, I guess. Autobahn is sort of a web native type thing. It's designed to work well with web clients, and so it supports WebSockets for the main transport. That's the default, and so that works really well if you've got like a. Does anyone not know? Does everyone know what WebSockets are? Okay. So I mean, they're basically just a TCP connection, but they work over sort of web servers. So there's a lot of infrastructure over there for those. You can also use Autobahn with just normal TCP connections, Unix sockets, as well as Unix pipes if you're on. So that's for communication on like local machine. So the transport layer of Autobahn is pretty well separated and specified, and it would be easy to add other transports if we wanted. And then sort of the next layer up, if you will, is serialization. So that's like now we can get bytes somewhere on the internet, on the network, and now we need to decide, well, what bytes are we going to send? And so it's important to specify the serializations really well, because we're talking between programming languages here too and stuff. And so the basic serialization that Autobahn uses is JSON. Lots of languages have JSON. It's easy to use, and it's pretty widely supported. So every Autobahn implementation, every WAMP implementation has to support JSON. All the Autobahn libraries also support MessagePack, which is a binary serialization library. It's really good. It supports tons of languages. And so all the Autobahn libraries support that. Not necessarily everything else does. And then we also have a couple sort of experimental serializations that only work with a couple of the libraries and with Crossbar itself. Crossbar does do translation. Okay, so if you've got one component that can only speak JSON, and you've got another component that can only speak MessagePack, they can still talk to each other. They can still make RPC calls to each other. Crossbar will translate those. And then there's also authentication. The way the WAMP spec and the way Autobahn deals with that is a concept of a realm, and within a realm, so every WAMP session, every sort of WAMP connection joins exactly one realm. And within that realm, you can have any number of roles that can have some pretty fine-grained permissions. So you can specify little pieces of your URI space and give permissions to do registers, calls, subscribes, and publishes. And there's a few other things you can do with that too. I won't really get into that, but you can do several other interesting things with revealing callers and callees to each other to do some more advanced stuff. And so sort of connected to that, but separate, is the concept of authorization. Okay, so authentication is like, is this client, is this component allowed to talk to the router at all? Once you're there, though, you can do the authorization of particular actions. So you can say, well, this client, sure, it's allowed to connect to this realm, but it can't register any functions to call, or it's not allowed to do any publishing at all. And that authorization is all within a URI space inside WAMP. You can do pattern matching on it. You can do you can also just register other WAMP methods to get called to do completely dynamic authorization. And you can also kind of use rules built into Crossbar itself. So all of these things I've been talking about are sort of all the components within the WAMP sort of thing you've got set up are symmetric. Everything can do potentially, if they're authorized and so forth, can do registers, calls, subscribes, and publishes. Okay, so that means that once your web page is connected to the router, some component that's running in the data center can call a method on your browser. Okay, or your browser can publish its own events and stuff. And so you have this sort of, you don't have to worry about sort of who's a server, who's a client or anything. There's just components in the system and they can all do everything once they're connected to the system. And then sort of the last piece of the thing here is crossbar itself, which is a WAMP router. And so it's not the only, like I said, there's a couple of third-party routers. There's one in C++. It's written by some guys in Toronto. And the other one's in PHP, I believe. And so anyway, so crossbar supports a bunch of different authentication techniques. I'm not gonna get into the authentication and authorization stuff tonight. There's already too much to talk about. But it supports enough to do sort of a lot of different patterns. And this is authentication of just sort of the WAMP connection, if you will, right? So you can still have, for example, you still have like a web framework somewhere involved here. And so you can do other stuff on top of this or sort of beside this, right? So if you need to do OAuth or things like that, you can build that in, like you can connect the streams, if you will. We talked about authorization. So crossbar supports both just configured sort of authorization things that you can say, assign permissions in sort of a static or in a pattern matching sort of way in your UI space, but you can also do completely dynamic things. So you could register a component that does Postgres lookups and decides, or does like, did this guy pay his bill? No more WAMP calls. And yeah, so crossbar itself is written in Python with Twisted. Internally, it uses WAMP for its internal communications with sub-processes. So it's using pipes to do that. So when it starts up worker processes, it uses the Autobahn libraries and uses WAMP endpoints to do that internally. And it also exposes a WAMP API that you can use as a component. So you can subscribe to certain events. You can, for example, I'll show you in the demo, you can listen for when like any client at all connects successfully or leaves. And there's other stuff you can do, right? So you can interrogate it for active registrations and things like that. There's also, not out yet, but there's what's called the Crossbar DevOps Center sort of coming out, where you'll be able to use a web service to control a Crossbar instance that you're running on your own infrastructure. And that also uses WAMP internally within Crossbar to do that. It comes with a REST bridge, so you can sort of easily bridge like a REST style API into WAMP calls. So for example, you can turn a REST endpoint into a remote procedure call to some other component in your system, and then when that component returns its answer, then the REST bridge sort of finishes the web request and sends some JSON to your client. So that's a real easy way to hook into. There's a lot of web services out there that use REST to communicate. right? So you can hook into, you know, stuff like GitHub or Travis and that sort of thing really quickly. And that works sort of, you know, both ways. That works for all the different bits of WAMP. And then, like I sort of hinted at earlier, Crossbar also does a bunch of generic kind of web services stuff. So you could run this stuff off Nginx or something if you wanted, but you can also just use Crossbar to do, you know, file uploads. It has support for doing sort of the old style like Comet, Ajax, long pole stuff. If WebSockets isn't supported, you can do reverse proxy stuff. There's support for WSGI, which is the Python sort of CGI web services thing. You can just do straight up CGI, and you can even just publish like static JSON stuff. So if you want to like kind of hang configuration information off of URIs and Crossbar, that stuff's all ready to go and built in. So I don't know, should we have a pee break? Or should I keep going with the demo? Okay, yeah, I guess, so one thing I didn't mention was that this stuff's all open source. Okay, it's on GitHub, it's ready to go. Crossbar itself, the router is GPL licensed, but all the other libraries are MIT licensed. And so, I mean, you know, should I say your question on the microphone? Anyway, so yeah, Eric was asking, you know, why would you do this? Do you want to ask your question again?
So I think one of the things that I had kind of missed that is a huge pain with microservices, not huge, but it's a big enough of a pain, is authentication and authorization. So, you know, if you've got an authentication service that basically verifies somebody, like how do you pass around authorizations for things? How do you verify that somebody is authenticated? So with Feathers, we use JWT, so JSON Web Token, and so you can encode stuff in the web token for what they have access to, what the user has access to. But it's also what I was asking Mike is what's the big benefit of using something like Crossbar or using something like Crossbar and Autobahn? And I kind of have an answer in my head, but I want to hear what he says. For doing some of this stuff rather than home rolling it yourself, where you're just using, you know, WebSockets, or you're just using HTTP requests to talk between services.
Yeah. So you mean, yeah, like it can be really tempting to take like a, you know, WebSocket's pretty easy. You can send messages back and forth. I mean, you know, that can certainly work for simple use cases, but as you start building out your services, you are going to need at least some of the features that a thing like Crossbar has. It doesn't have to be Crossbar, but I mean, so like Eric alluded to in his question there, like you need to do authorization on a pretty fine-grained level sometimes. But you also just need to do, you know, even just simple things like message framing and, you know, what if you have a client that isn't speaking, it says it's doing UTF-8, but it's actually not, and just some basic sanitization of incoming data. Right from that can be from like this sort of like serialization layer up to higher levels. And I mean, there's hundreds of thousands of hours of different people's time that have gone into these libraries and this stuff. And you're not going to replicate that quickly yourself. So if you're Google or Facebook, you know, yes, you should write your own, or you could write your own, but there's, yeah, I mean, you will need a lot of these features, and a lot of them are already done. Yeah. So I mean, yeah. Like the other thing is the Autobahn libraries also give you a really good WebSocket implementation in for at least the Python and C++ libraries. They have a fuzzing-based test suite that's also open source that a lot of people have used to test their own WebSocket implementations. And I mean, like, I don't know, Eric wanted me to mention like Mozilla is using at least the Autobahn WebSocket APIs to build their pusher service. So they're doing close to, I don't know, 700, 800,000 concurrent connections right now with running on PyPy in Python on like a 30 machine Amazon cluster, and are planning to expand that. So I mean, you know, getting that kind of feedback on your own homebrew system is going to be tough. Like, there's lots of problems that come out of that, and we've fixed a bunch of them. And just having other people writing code that's versus the spec helps the spec get better too. So there's lots of edge cases, weird stuff that you're just never going to sort of think about at first that has come up and sort of has to be dealt with and fixed, both on a sort of on a protocol and a specification level, and also at the sort of code level.
I was just gonna say, like, so I don't know anything about microservices. We run like Ruby on Rails app. How would I use microservices? What is the difference? Like, what's the, if I wasn't using this, what would I use? Like high level.
So that's kind of a little bit of what I was talking about at the beginning, and like, you know, there's pros and cons to using microservices. So like, you can, as a Rails app, what you might do is you might split up your app, like I was saying, payment or, you know, user management or something else. Like, every app's going to have different domain kind of models, but typically you might split up your app into different services as you're seeing one service get a lot more demand than another, especially if you're having trouble scaling or you want to, I don't know, like scaling, it's funny. Like, people think scaling is such a hard thing, but it's shitty from a DevOps perspective, but it's not that hard to scale even a Rails app. I mean, like, if you're deploying on Heroku, drag the slider, right? But it's going to cost you a lot of money. So really, it kind of comes down to cost, I think. And then personally, I think you kind of need to look at whether hiring somebody to do DevOps is worth it versus using a service. I mean, that's a corporate decision. But if you're going to go and split up your services, I mean, a pretty common first step is that people just use a REST interface over top, right? So that you'll have one server running here and one server running here, and they're running different services, maybe shared models or something if you're talking about a Rails stack, and you're going to be making HTTP requests from one to another. You know, some do WebSockets, some do whatever. What this does is this would take out, and Mike can kind of talk about it, but this would take out a lot of the, so this gives you kind of a few different mechanisms that it abstracts it. So rather than you having to roll your own pub subsystem or having to use Redis or something to do the publish subscribe, this kind of wraps it all up, but also allows you to talk between services really easily. Because with REST, like, you've got a REST response cycle, right? Which is fine, but what if you need to push data from one service to another, right? Then you're looking at WebSockets or some of the other transports that this already provides.
Can this sit between, be like a communication layer between two, like, let's say a Rails app and like a microservice or something like that? Like, we want to start branching things off.
So
like smaller pieces.
yeah, and so to expand on what Eric said, like, a way to think about it is, you know, let's say you've got something in your Rails app or your whatever, your code, and you've got this sort of like separate subsystem there, right? And you've written a nice API for it, and that's cool, but it's just sort of Ruby calls to this thing. That might be a good point to decide, like, if that's a pretty well specified thing, you're pretty sure that that's like a separate thing that you need to do for your your software, that might be a good place to start with sort of microservice thing, right? So you can put that stuff behind an even better specified API. So for example, with WAMP, you would spec out a little URI space for your remote procedure calls, and so you'd write that up, and you might say, okay, here's the API calls you're allowed to make into this service, and here's what it gives you back. It returns values. Maybe sometimes it publishes some events in response to stuff, and then you have a really well-contained piece of functionality, right? So you can unit test that, you can integration test that by itself without connecting it to the rest of the system. So I mean, that's all great, but you can do that in Ruby, right? So you can do that in Ruby with your separate module and whatever. But then once you move to a sort of services thing, if you need to scale that, for example, you can run like 19 copies of the services behind that. But you can also start playing with different implementations. Okay, so now you could drop in a C++ implementation and see how that works, or you could drop in a different implementation that tries out a different database framework or whatever's behind that. And so you get more flexibility on the one hand. I mean, you also in some ways get less flexibility with some of the downsides that Eric was talking about. I think so that's one way you can use it. Another way I think that you can use microservices successfully is to kind of start, if you've got this giant monolithic app and you're trying to like figure out like, well, we want this other team to handle part of it. And that's a way you can kind of, leverage, I guess, a technological means of like organizing teams internally and stuff too. It depends. I mean, I guess I would say in some ways it's kind of like a way to take something that's already a good, well-specified kind of API thing and make it even more formal, and just ends up giving you a lot more flexibility with it.
So if I want to start creating like Rust, like microservices, I guess, like microservices, like processor intensive parts, like with this stuff.
Yeah, exactly. So now all of a sudden you might have, now as far as I know, there isn't a Rust WAMP implementation, but if there were, or I mean, even if there wasn't, you could write one, and it's all open source, so that's cool. But then yeah, it would start talking to crossbar. So what you could do is take your existing code that works, you can sort of redeploy it in this different way. But then now you can easily plug in, some of them can be Rust, like you could plug in 1 out of 20 workers is the Rust one and see how it works, right? Maybe it blows up, but then only 20% of your customers are sad because, yeah. You can use it for, you can use it for load balancing like that, but you can also just use it as like a way to have the same API presented by a completely different processor, completely different language. Yeah. Well, you don't have to rebuild, you don't have to redeploy, you don't have to do anything. You just have to like run this other thing, and all of a sudden 20% of your API calls are going through this experiment. Right. Yeah. Was there another? There's another question. Yeah. Okay. Cool. All right. Yep. Yeah. So the question was sort of, there's a lot of stuff about IoT or Internet of Things on Crossbar IO. And that's one, for sure, that's one sort of big use case that people like to talk about. I mean, in some ways it's no different than any other computer, but I mean, the sort of Internet of Things is like, there's lots of computers all over your house now. And so you get some of these kind of problems like, well, I want to, I just have this Arduino and I want to like measure the temperature in my garage, but how do I make that talk to anything useful, right? And so one answer is, well, you could run a crossbar router on your home computer, and then your little temperature gauge or whatever you could make just REST calls, or it can actually make WAMP calls, and so so you don't have to worry about doing low-level socket stuff from your embedded device and so forth. You just make calls, sort of API calls directly. Yeah, absolutely. Now, part of so oh yeah. So sorry, the comment was just that that there's a lot of with Internet of Things devices, and could WAMP be a way, past that? Sure. I mean, crossbar is getting a lot of interest from Internet of Things stuff, and that's a big part of the reason why there's this C library coming out, is because a lot of those really tiny embedded devices don't have a C++ compiler. You can't run C++. And so that'll sort of help with that. If you think of, do you know what MQTT is? That's sort of MQTT is sort of the pub sub portion of crossbar or WAMP. And so I mean, yeah, so somewhere where you're using MQTT, you could certainly use crossbar as well, or instead, or whatever. And actually, my dad's been super interested in some of this stuff, so he just set up some. I have a beehive, and he just set up some temperature monitoring and weight monitoring on the beehive that's using crossbar. So it certainly works with Arduino, anyways. So yeah, so let's. Do you guys should we take a break, or should I just go on with the demo and then? Okay, so I see that there's lots of people messing around with the demo. So this is like kind of a little cheesy demo of I don't know. There must be a lot of people connected. Sort of a collaborative drawing program. Okay, so there's some shared state here. Different clients can connect and do stuff, right? And so this sort of demonstrates a bunch of the sort of interesting bits of WAMP. And so what this is here, this is running on a machine in Toronto, and so there's a Node.js backend sort of. I mean, I'm going to keep using the words front end and back end. There isn't really that concept. I said like this stuff's symmetric, so but there's sort of the back end type device. Okay, so when you disconnect, all your state goes away on the server on purpose. I'll show you that too. So that's on purpose. And so where was I at here? Yeah, let's just let me start showing you some code here. So yeah, there's a Node.js sort of backend thing, and no, I don't want to do that. No, here we are. Okay, so so there's this. Let me just tell you so there's a pretty simple little WAMP API that I have here. So on the back end, I have a media.click method that you can call, and that's what your client calls whenever you click on one of the squares there, and you call that with just the XY coordinates of your thing. There's a get board call, so that just gets you the state of the whole board there. So that's what the browser is using to draw it. You can ask how many clients are connected, and then the backend also publishes two different events. The board update event is to just tell you that the color of one particular cell has changed, and the board invalid event is used to say like refresh everything. And I use that when a client disconnects. Okay, and then the browser, the JavaScript that's running in the browser just subscribes to those two events and calls some of those methods. So it's a pretty simple setup, but it's small enough that I can show you all the code here tonight, which is cool. So the Autobahn JavaScript library works in the browser or in Node, and so you gotta sort of install it. It's on npm. If you're doing browser type stuff and just trying it out. It's also on S3 and Amazon, so you can just put like one line script thing in your web page and it'll be included. So it's, and there's also there's a demo router, demo.crossbar.io. If you just go there in your web browser, there's a bunch of other like pretty cool sort of fully worked out examples. And you're also allowed to use that as your crossbar router if you're just kind of messing around, right? So don't launch Twitter 2 with that as your router. But and so the way you interact with these Autobahn things is to make a connection. Okay, so a connection sort of abstracts your where the router is that you're going to connect to and the realm. Okay, so like I said, I'm not going to go into the authorization and authentication stuff tonight. So this realm just allows everyone to do everything. Okay, so there's no permissions here really, and there's no authentication either. Everyone's just allowed to log in. So the connection object accepts a bunch of other options, but it basically gives you two hooks to sort of put your code in. So the on open callback is called when the WAMP session is connected successfully, and then there's an on close one as well if you need to do any cleanup stuff. And so that's just called with this session object, which is your WAMP session. And for this demo, that first line there, I'm just saying, I'm just assigning to a global variable to make the demo easy to understand here. So all of our actual interesting code is going to go into this on open function. And all this stuff would sort of run in window.onload or, you know, whatever, some sort of initialize function. Okay. And then you just tell the connection to open itself, and it'll open, and then it'll keep reconnecting and stuff. There's different options you can give it for, you know, to never try reconnecting or whatever, but by default it'll just keep reconnecting. Okay, so to flesh out a little bit that API I showed you earlier. So in the front end here, we're going to write this onboard update. So one of the pixels on the little board there changed, and we want to know what it is. So the way we subscribe is we just take this session object and call subscribe on it. So the first arg is a sort of WAMP URI. So that's the name of your function. Okay. The only thing that's special about those names are the dots. So you can do pattern matching in between the dots, right? So just to sort of briefly get into the authorization, I could say media.star can be called by the front end, but the front end can't register there. But I could, or it could be like, you know, media.admin.star, and so on.
Is that session object kind of an abstraction over top of like all of the different protocols?
Yeah, so that session object represents the WAMP session, and so when we specified our connection here, some of the options I sort of glossed over, you can specify different transports and stuff there. That's where you would tell it, I want to try a couple other different ways to connect or whatever as well. And so I've sort of simplified this as much as possible. You could specify, for example, 2 or 3 different transports to try, and stuff like that. So once all that's happened, the framework calls on open with the session. Okay. And so that session's ready to go, and you can do stuff. So it has like a subscribe, a call, a register, and a publish. Okay, and similar on when the complete board is invalid, we're going to subscribe to that event too. Same way. And that's all we need to do to sort of start up, and then I just call the method right away to get the initial state of the board here. So yeah, I just used a global for this because it's easy. So when you click on one of those squares there's just an on-click handler that calls this pixel.click with the X and Y coordinates of where you clicked. And that's like 0 to 16 and 0 to 16, right? I've got like a 16 by 16 little, 1990s icon thing here. And so if we have an active session, what we're going to want to do is call that API. that I promised would exist in the back end, right? So I'm saying media.click, which is again the WAMP URI. And then the second argument is the list of positional arguments. And then you can optionally, specify a third argument that's a dict or a map or, just an object, but it has like keys and values. So you can use that for sort of keyword arguments. And then you can also, there's a fourth option you can pass, which are options to the call itself. I'm not going to get into that stuff, but there's, maybe you can ask me after if that's important to you. Okay, so that's how we make a call. And this call, you can see we're not doing anything about the return value, right? So in this case, we don't actually care about the return value. We're just making this call off into the ethers. Okay, oh, that's a good question. So I'm gonna get into that in a second. This library doesn't do callbacks, it does deferreds or promises, and that's pluggable in this implementation. There is one of the third-party JavaScript libraries does the sort of callback style instead. Yeah. So I do a call later where I'll show you that, but you can plug in ES6 promises. By default, it uses when.js, but you can ask for ES6 promises instead, or jQuery deferreds. That's all it supports right now, but in principle, it could support other ones. Okay, so now this is sort of the this is the other thing we subscribe to is, so if the backend and says, hey, the whole board's invalid, what are we going to do? Oh, here's the answer to your question here, right? So we call this media.getBoard method, and that returns us a deferred. So then so this is using when.js, so we call .then and give the callback there. So basically what this says is go and call that method, and whenever that other component returns its value over the network, call this function here. And so that method is always going to return this sort of 16 by 16 grid of colors, of RGB values, okay? And it's sort of off the screen there, but I think you can imagine what that does. It just sets the background color of the appropriate cell. And then similarly for the client counting. Does that answer your question about the deferreds? Okay. Yeah, I'd showed that line before, but does that sort of make sense? Or I mean, there's a lot of code there, but it's fairly straightforward. Okay, so the reason I'm doing that in this demo was to when a new client when a client disconnects, I delete all their state, big chunks of the board going away, and that's when I tell, instead of like sending an update for every little cell, instead of publishing a whole bunch of events, I just say, hey everyone, just get the state for me again. So the reason I did it this way was sort of, I find that there's a reasonably common pattern where you have a client that you want to connect and register for updates, but you also need to get some kind of initial state, right? So what I do is you'll usually so you sort of connect, you register for all the updates, so you're for sure good to go, and then you kind of ask for the initial state. So you're so I mean, part of the reason was just to sort of that. And so your actual question was about batching of events. I mean, there's no support for you to decide how to batch the events in the API itself. Under the hood, they are batched, but I mean, you just publish an event and then they're sent out. But they are sent. I mean, if you have 10,000 subscribers to this call, it doesn't send out 10,000 of those things and not do any other work. It is sort of, yeah, you'll get shared out like it won't just blast 10,000 of those events and then do other stuff. But yeah, there's no API to control that yourself. So yeah. So this is the simpler one. This is just the board update one. And so this sort of shows you the first, so similar to when you make the call, when you actually sort of get a published event, you're passed a list of arguments and then a dict of keyword arguments. So in this case, there aren't any keyword arguments. So I just extract, but I'm expecting 3, the X, the Y, and the color value. So I just extract those from the args, and then we update the cell. So yeah, and I mean, if you had any keyword args, you could grab those out too. So the question is, what's the difference between args and keyword args? That's a little bit of a Pythonism in some ways, the way I've written that. But the keyword args is a dict, so that you don't have to send the arg, if you will. So so you typically use those for like optional extra args, right? Whereas the other ones are positional, right? Like if you didn't send me 3 args, obviously I'm not doing any area handling stuff here, but if you didn't send me 3 args, this isn't going to work, right? And so the positional args, you sort of have to send, like you sort of define that as part of your API. So you say, I'm sending you 3 args, and it's going to be X, Y, and color. Always, I'm always going to send those. Maybe I also send you something else, like, I don't know, make it 50% opaque, or like this was from Mike, or you know. So you typically you'd use the keyword args for the optional stuff. Well, I'm just, the way I wrote that is sort of a Pythonism. It's not, it's part of the WAMP spec. And so under the hood, like down at the serialization layer, that's actually written out as a dict in JSON, whereas the args are written out as a list. And so similar here, we're just subscribing to that update. So that's pretty simple. So now let's, so I mean, hopefully that was clear enough for the front end. So how are we doing for time? Is that counting down? Okay. So now we'll look at the back end. So this is written in Node, and it's fairly simple. So we have a map, like a hash table full of the clients that are connected, and so we have a way to create a new client. And so the way I did this, so shared state is hard and filled with sadness, and so instead of having sort of true shared state here, this is each client has their own copy of a 16 by 16 array. And in this case, it's just an array of bools. So they either have or have not clicked on a square. And then each client, I just randomly assign each client their own color. And I didn't put that code in there, but it's just cycling through 3 different colors, right? So you're either getting red, no. So the question was, is there state in a microservice architecture? Oh, does this architecture have? Okay, so the question was, does like crossbar and WAMP provide any statefulness between the different pieces? So the answer is mostly no. There is a sort of experimental feature that's in the router right now, where you can save a certain amount of history on published events. Okay, so you can tell crossbar, for this WAMP URI, I want to save the last 16 things that were published to it. And then when you're connecting as a client, you can receive those events. And so that is state that the router keeps for you, if you will. But other than that, I mean, so for the most part, no. If you want state, you have to keep it yourself, right? So here I'm keeping my state in this map, right? So if this backend service happens to die and get restarted, well, all your state just went away, right? And so typically you'd have a database in there somewhere, or you'd have something, or yeah. So there's lots of ways to do your own persistence. There is one built-in way to do some event history, and that's done with Lightning. There's an in-memory database called Lightning, which is really cool, and that's what's it's using. For the history, optional event history on publishes, so you can ask Crossbar to save, say, the last 16 publishes to a certain URI, and so it'll keep those sort of for you and let clients catch up with those publishes without you sort of having to do stuff. So yeah, so that's called LMDB or Lightning DB. Yeah. So here, I wish those keys were close together. Sorry about the font sizes here. So yeah, so there we can create a new client. So let's see here. Where are we at? So when we're looking at the front end there, it called media.click, right? So the back end provides this method, board click, and this isn't the actual method that's registered at that URI. I'll get to that in a second, but this is sort of the way we when a particular client clicks on a particular square, all we're going to do is get that client and toggle the state of that square, right? So if you keep clicking on the same square, it's going to go on and off for you. So this is sort of that similar boilerplate kind of stuff I showed you before for the client. So now on the back end here, this is sort of the other end of those calls. Okay, so we're not doing session.call here. We're doing session.register, which says, hey, I want to provide the media.click function to be called. And whenever any client at all calls that, I want you to call back the client click function that's right above that says write me. And you'll notice I added a third argument called details there. Okay, so Crossbar will send you some details about this particular invocation of the call. So there's a few things you can use that for. What I'm going to use it for here is just to look at the session ID of the client that called me. Okay, so that's where I'm going to get these client IDs from, which I'll show you in a second. And then the other method I'm going to register was this get board, right? So give me the state of the whole board. And that's again similar. You'll notice I don't have args or keyword args or details there, right? Because I don't care. I'm just always going to send back the same data, the state of the board. And then, oh yeah, there's also that get client count thing. So that one's easy. I just implemented it right there in line. All it's doing is returning the size of the client's map. Okay, so let's look more. This client click method is sort of like one of the interesting ones. And so again, we have to unpack the args, because if you remember, the clients, your web browser, whatever, is calling this with just two args, X and Y, right? So now, we've unpacked those two args there, X and Y. And now that sort of board click method I showed you earlier, we want to call that. And so this is where that details thing comes in. So we're saying details.caller, and the docs will tell you like that's the session ID of the component that invoked this particular call. And so that's how I figure out which browser just called this method, right? So all that ends up doing is looking up the client in the map and then toggling the state of that guy's thing. And then we want to tell everyone, hey, this pixel here at XY just changed state. So we're going to publish. This is where we publish our event, right? And so again, it's pretty similar to all the other API calls. Just the WAMP URI is the first thing, and in this case, we're sending 3 args back, right? The 3 args that we expected in our front end thing, which is X, Y, and the color. And we can do options. There's a few options you can. all of these things actually have a few options you can send to them too. You can ask for an acknowledgement, for example. So you can ask Crossbar to tell you like, yeah, okay, I've actually sent that publish now, and a couple other things. This is again a bunch of code. This is just that board color out. So this is how we figure out which color those pixels are. And you'll notice each client basically gets full red, full green, or full blue as their random color. And then when we're mixing them together, we just take the max of each one, right? So if a red, a green, and a blue client all clicked on the same square, that square turns white. So yeah, so then the only other sort of interesting, I mean, so if you were paying attention, you would notice that we never actually added anything to that client's map yet. And so I talked a little bit about that Crossbar itself exposes an API internally over WAMP for you to use. And so this is the simplest kind of stuff you can do with that. So we want to, this sort of back-endy thing wants to know when a client joins so that it can make a new sort of state object for it. And then it also wants to know when it leaves so that it'll delete its state object. And so, so this is the join. So I'll just show you the whole code here. So we subscribe to these two events at the bottom. We subscribe to this WAMP dot. So everything that starts with WAMP dot star is sort of reserved. And so you need a permission to call that or subscribe to that. And so we're just asking the router here to tell us when any session at all has joined or left. And when that happens, we'll call the client joined or the client left thing. And then all we do there is extract the session ID and either create or delete the client, the entry in the hash table there. Yeah.
Like one of those subscribes, where like you can use like an asterisk, kind of a wildcard.
Yeah.
So like if you wanted to, because you have to call board invalid for both of them. It's kind of a shitty situation, but if you wanted to do like wamp.session.on underscore like asterisk, call board invalid, that work.
Yep. If you kind of lined the args up right and it all, yeah. I mean, so you can't, you'd have to say wamp.session dot, I think the pattern matching only works on a whole chunk of dot. I'd have to double check that, but yeah, so you'd have to say like wamp.session.star. But then, so yeah. One thing you can do though is so when you do that, then the sort of downside of doing that is then you kind of have to inspect the call. Like you have to look at the details and see which actual procedure was invoked. You know what I mean? WAMP.session.onLeave or .onJoin, because inside your function call you don't know anymore, right? Yeah, but yeah, but yeah, absolutely, you could, yeah. 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 So there, I mean, I didn't sort of get into the whole kind of router API that there is, but there's, you know, you can ask for example, you can ask to be notified whenever any procedure call at all is registered. So you might want to do some of that stuff just to like publish analytics or something, like, or security auditing type stuff. Yeah. So it's called if you're looking this up on crossbar.io, this is sort of the WAMP meta API. I think it's in the spec as well. But yeah, that's all I had for the demo and stuff. So yeah. Oh, look, 14 seconds. So yeah, if there was any other questions, and yeah, crossbar.io or autobahn.ws to okay.
Once you use this crossbar and Autobahn, how does it help you to scale your app
facilitate or scale in that sense. You're not relying on that. Okay, well, so yeah, in this I had just the one backend. When you're registering RPC calls and stuff, you can there's registration options to do like a round robin type registration. So you can have, for example, you can have 6 of these backend components register at the same WAMP URI, and then crossbar will round robin to you. It's not done yet, but there's a feature coming do least busy instead of round robin. And so there's some balance between how much network traffic you're causing and how much stuff you're saving. But you know, if you have like a CPU intensive thing you want to farm out somewhere, this is a good choice. Because you're gonna have sort of occasional network traffic in order to spin off a lot of CPU somewhere. And so there's definitely that sort of balance when you're looking at scaling like a sort of just in your data center type thing. Yeah, you can do some sort of interesting patterns like that. Or you can sort of set up your URI space such that, you know, I don't know. It depends a bit, but yeah. So some of that comes down to API design and stuff. But I think you get enough tools already to do a lot of interesting stuff with crossbar, and there's definitely, I mean, those features are interesting and certainly coming down the pipe.
Awesome, thanks, Mike. So I had kind of a quick side discussion. I guess like another good use case for stuff like this is, you know, if you've come from Rails land and you're using, like Josh is using delayed job, but there's also rescue is another alternative, right? Which uses Redis, which uses pub/sub kind of mechanism, but it's still typically only a one-way pub/sub, right? So you might have a worker that's running that is waiting for a job to come into the Redis queue, and then it works on it, and then when it's done, it, you know, maybe posts to the endpoint or does something. The nice thing with stuff like this, where you actually have two-way publish subscribe, you can actually send progress updates a lot easier. So doing things like that, that's a good use case.
I should also, I meant to mention earlier, but yeah, you can actually, with the RPC calls, you can do progress updates and incremental results with the RPC call as well. So that's built into that. Or of course, yeah, you could use pub/sub to do that.
Sweet, yeah. So pretty extensible and pretty flexible if you're looking to do that. I actually even had a thought that because it's very RPC based, it might be a good candidate. I don't know, but it might be a good candidate for Lambda functions actually. So man, it might be something to take home project. Anyway, thanks again, Mike. And thanks again to our sponsors, Clio and Pixis Innovation, Last Best here. And thanks for coming out, and we'll see you guys next month. We're going to talk Docker.